Yeah.
Go ahead.
Cisco.
Brooke. All right, today we're gonna investigate quadratic functions. Now, what is a quadratic function? What are the characteristics of a quadratic function?
It's got something to squared.
It's got what's
Your
squared?
variable x.
The x value is squared, so it's a second degree. What's the shape of it? It's a U-shaped and it could be upside down. What things does a parabola tell you? What are the important parts of a parabola?
The maximum and minimum.
The vertex or the max or the min. So if it's a U-shaped, your vertex is a minimum. If it's upside down, it's a maximum. What other thing did you know about parabolas? It has a what? It has a axis of symmetry, a line of symmetry that if you folded your graph over, it would be symmetrical. It has a y-intercept. All quadratics have one y-intercept. They all do. How about that other intercept? The x-intercept. Do all parabolas have x-intercepts?
Nope.
Sometimes they have none, sometimes there's one,
It could be
and
shifted.
sometimes there's two, like these three examples are showing you. 0, 1, and 2 x-intercepts. Okay, and then there's also a bunch of ordered pairs that satisfy the relation. Is a quadratic relation a function?
Yes.
Yes, it passes the vertical line test. So here are the characteristics of a quadratic function. Over the past few years, these are the three forms that you've worked with. See if you can recall this. We're going to do this all in one day. Transformation form looked like this. Y equals a number, sometimes there was a number there, and then it said x minus h squared plus k. Do you remember the other name that we called, it's in this class it's called transformation form.
Vertex.
Vertex form. Why did we name this vertex form? Because the vertex and the axis of symmetry were right there for you. There was no math involved. Okay, the next form, polynomial form. We call this standard form. What was nice about standard form is this C value was the y-intercept. And also it told us it was the A value tells us if it's up or down. And this form is one that we really didn't spend a lot of time on, but you will in this class. It's called x-intercept form. What does this give you? The x-intercepts. Okay, now why do we need to know all three forms?
They're all useful.
They're all useful, very good. They're all useful in finding a part that we need to graph. Now, can you go from one form to the other? Yes, and that's what our focus is tomorrow. I'm going to start it today, but I'm going to do a little bit tomorrow too. You could take any one of these forms, and there's different ways to figure out what the other form would look like, okay? So let's start. We're going to take each one of these forms, and I'm going to show you how to graph them completely and find all the information. So what we're doing today is we're going to do one example of each, and your homework is to do the two that are remaining for samples, okay? So, Rachel, example 1. Can you tell me what form this is? No. It says it right there.
Where? Transformation.
Transformation form. What was the other name we called it? Vertex. Now, what's nice about this form is what? What are the things that are easy to identify when it's in transformation or vertex form?
Your vertex. Your y-intercept.
The y-intercept?
I don't know, your vertex.
The easiest things are, is it up or down? You look at this number and it's up.
It's happy, it's positive.
It's up. So if it's up, the vertex is gonna be a what? A minimum value, not max. The axis of symmetry is very easy when it's in this form. What is it?
3.
Don't say just the number,
X
say,
equals.
the axis of symmetry is a line. X equals 3. And what's the vertex? Now, this is all old stuff. Do you guys remember this?
Yeah.
How do you graph the axis of symmetry?
You do a dotted
You do
hash
a-
line.
Why do we do a broken line and not solid?
Because then they'd be confused for part of the graph.
Very good. So 3, -4 is our vertex. Now, our graph is gonna be shaped like this, right? It's a
Yeah.
U-shaped. So could you, now that we have the vertex, can you add anything onto this list? What's the domain and the range?
It's all real.
All real numbers is your domain, but what's your range?
Greater
How do we?
Go ahead. Y is greater than or equal to
negative.
-4, because this thing's gonna be shaped like a U. So all the Y values that are bigger than -4 are part of your range. Now, why is the domain all real numbers? Because you can put any number you want in for X. It's not like you're taking the square root of a negative number. You can put any number you want in for X, from -infinity to infinity. Now, these two pieces, you need a little bit of math to do. Now, what did you learn years ago? How to find the x-intercept. It says it right there. You're gonna set y equal to 0. Well, if we put a 0 right here for y, do you agree, and I didn't give you a lot of room, so write 2 times x minus 3 squared minus 4 equals 0. All I did was rewrite it reversed. How do you solve this for y, for x now?
What question?
Yes.
You just do that in a calculator and do your bounds.
No, I want you to do it by hand.
Okay, so then you're gonna add 4 to the.
Add 4. Add 4, what else, Nick?
Divide by 2.
Okay, so what do you have? Can I do that? Because I don't have a lot of room here.
Okay.
What's 4 divided by 2? 2.
And
Then you're gonna take the square root of both sides. I don't know why I put that in parentheses.
Yeah, I don't know, okay,
You don't need
x equals 3 plus or minus root 2.
X is equal to 3 plus or minus root
You know,
2.
you get 2 solutions, so you're gonna get 2,
Where is 3 plus or minus root 2? Where is 3 plus or minus root 2?
I don't know, solve it.
I have it right here for
Right
you.
there.
These are exact answers right here. These are, what kind of answers? Estimated. Why do we need the estimated answers in this situation?
Helps better visualize.
Where is 3 plus root 2 and where's 3 minus root 2? So 4.4. So where is 4.4? It's about there. And where is about 1.58? It's about there. So this ordered pair is 3 plus root 2. And this one is 3 minus root 2.
Do we have to label that?
Comma 0. Well, sometimes it's labeled. If you have it here, then I know that that's what it is.
Okay.
Now, how do you find the y-intercept?
I guess it does.
You're going to plug 0 in for x. So you've got y is equal to 2 times 0 minus 3 squared minus 4. How do you solve this now?
Parentheses first.
Do parentheses first, so you get 9.
Operations, yeah.
9 times 2 is 18, and what's 18 minus 4?
14.
So this graph is hitting the y-axis at 0, 14. Do I have enough?
No.
1,
About
2,
like
3,
12 maybe.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We'll say it's right there. Now, could you
Kind of draw it out.
give me another point that's symmetrical to this point right here?
Yeah.
You can go across 3 units this way and put a dot. Because you want your graph to be balanced, right? So if you were to sketch this graph, this is what it looks like. skinny, whoops, sorry. But that's a graph of it. Now, is there a way to take this equation and switch it around? And why would I want to switch this around? Why would I want to rewrite it in standard form? What's a reason to want to put this in standard form?
So you can get that,
Another way to get the
minus.
y-intercept. Let's do that. How do you square x minus 3? You remember how to do it the fast way?
X squared minus, I don't know, 6x plus 9.
So that's what that is. You should have learned that in 9th grade, how to square that quickly. Then you're going to multiply everything by
2.
so 2x squared minus 12x plus 18 minus 4. And simplify it a little bit more.
Put it like terms.
Like terms, which are these two right here.
Yeah, plus 14.
And what is this 14? This is standard form, or polynomial form as your book calls it. Polynomial form or standard form. This is your y-intercept. Why is this your y-intercept? Because if you were to put 0 in here, this would cancel out, this would cancel out, and 0, 14 is your y-intercept. Now, how do you write this problem in x-intercept form? This is the part that's new to you. This is what you're going to think of this. This is the new part. Do you know what the a value is? You know what the a value is? It's the leading coefficient, which in this question it's a 2. Do you know what you're going to put in these two parentheses? Your x-intercepts. So 3 plus root 2. And why am I having the opposite? Because we always, when we have something written in, if it's factored, like for example, I'll give you an easy one. If you saw something like this, what are the x-intercepts? It's the opposites of these. So it's 3 and negative 2. So that's why these have to be minus. And these are your two x-intercepts. So this is x-intercept form. You need the a value, and then you need the x minus, and then these are your two x-intercepts. Now, what if our graph was like this? How would you write this equation in x-intercept form? What are the x-intercepts?
None.
There are none. So this is a trick question. When they ask you to rewrite this kind of one in x-intercept form, you can't do it. Say none.
How does it look in other forms?
Well, what do you mean in the other form?
Okay, so you can, so when,
This is transformation, and then polynomial form is when it's stretched out
but it
like
can
that.
still be written in those other forms.
Yes, the other two, yes, 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 yes. Now, how will you know when it can't be written in x-intercept form?
And you don't cross the x-axis.
When you don't cross the x-axis, what's another reason?
You have a variation.
When this number right here under the radical is a negative, good. Okay, let's look at the second example. Here's polynomial form. What's so special about polynomial form, or standard form as you probably know it? And this abbreviation is, sometimes they'll write PF, polynomial form. What's nice about polynomial form are these two things right here. Other than that, you got work to do. So this leading coefficient, if it's positive, will tell you if it's up or down, and this number is your y-intercept. So as far as this example goes right here, let's apply this and see how many of these 8 items you can do. Is this up or down? Up. So if it's up, what's our vertex going to be? A max or a min? A min. All of these domain and range, domain will be all real numbers. Domain. Range is going to depend on your vertex. And the other thing that you can do on this one is what? What's this? The y-intercept, 0, 3. I'm sorry, I'm in the wrong spot. Yeah, 0, 3, right here. Y-intercept. So that's all we know so far. Everything else has to be mathematically computed.
How'd you know it was all real numbers?
Because you can put any number in here for x. Is there any restriction? Is there any number that you can't square and add 2 times? Is there any problem? The ones that have problems are the radicals or a fraction. You don't want a 0 in the denominator of a fraction. So those are the ones you want to look for. But as far as, this is a quadratic, it's all, the domain is all real numbers. Now the range is going to be different. Your vertex and your axis of symmetry. Does anybody remember in 9th grade how you were taught how to do axis of symmetry? X, there was a formula. X equals, anyone?
Something over B.
Oh,
B over 2A.
Good, negative b over 2a. Now, what is the b value?
2.
So it's negative 2 over 2 times, what's the a value? 1. So what is your axis of symmetry? X equals negative 1. It's a vertical line at negative 1. Let's graph it. X equals negative 1. Now, what important point lies on that axis of symmetry? The vertex. How will you find it? You're going to plug negative 1 in here and solve for y. So if we put a negative 1 in here, what is negative 1 squared? Plus 2 times negative 1 plus 3. What do you get? 1 minus 2 plus 3 is? Anyone? 2. So your vertex is the ordered pair negative 1, 2. Now, can you tell me, is this going up or down? It's going up. So it's going to look like this, right? So where, oh, and we know the y-intercept. We said it's 0, 3. So let's put that in, 0, 3. And we can fudge that point in there too. So it's looking like this. So can you tell me where this thing is hitting the x-axis? It's not. So there are none. Are there any other ways that you learned in chapter 2 or in 9th grade or in 10th grade, another way to how to find the x-intercepts? You got a bag of tricks here, you guys. You guys better know several ways how to find the x-intercept.
Factor.
You could try to factor it. This is not factorable. I don't know what 2 numbers that multiply to give you 3 that add to be 2. So you can't factor it. Do you know any other ways how to find the x-intercepts?
Oh, quadratic. What's that? Oh,
What's that formula called?
yeah, quadratic.
The quadratic formula. But guess what? I'm not going over this. But you're going to find out when you put your A, B, and C in here that the number underneath the radical, which is called starts with a D, discriminant, is a negative number. And you learned in chapter 2 that if the discriminant's negative, there are no x-intercepts. So you should start to see a lot of connections here. A lot. So when you do this problem, you're going to see many ways that there are no x-intercepts. In any other way you could find the x-intercepts, how about complete the square? Do you remember how to complete the square? You swing 3 over, half of 2, square it. You're going to find out that you're going to get a negative when you take the square root. So there are no x-intercepts. But can you tell me what the range is on this?
Greater than or equal to 2.
Yep, y is greater than or equal to 2. Now, I only have 3 points plotted. It's kind of weak. How could I get some more points? You can plug in numbers. Now, what kind of numbers, common sense, what kind of x values would you go for? 1, 2, negative 2, negative 3, good. And you can just plug them in. I'm not going to go through that. Okay, now, another thing I wanted to go over with you. What form is this called? Polynomial or standard form. Can you rewrite this another way? Can you? Yep. Did your teacher ever teach you how to write this and I know I did in Algebra 2 last year. I taught you how to bring this 3 over. Where am I bringing it? I'm just inching it over here. Just enough room that I can take half of this and square it. What's half of 2?
1.
Square 1. I'm going to add 1 here, but I'm going to take 1 away. Why do I want to add and take it away?
So that equals each other.
Because it's nothing. I can't add something to one side unless I'm about to do it to the other side. So no one has the right to add something to one side unless you're going to add it to the other side. Well, who says I'm adding something to this side and not to the other? This really, if you think of this as on the other side, it's a 1. But 1 minus 1 is nothing. So it's like you did nothing to this problem. Now, why did I want to add 1 and subtract 1? Because this is now factorable, and 3 minus 1 is 2. So guess what I just did? I just took my polynomial form and put it in vertex form. Now, I could have cheated and did this. I could have found what did we say the vertex was when we did it here? I could have cheated and said, okay, it's as long as you know that form, negative b over 2a. How do you write this in vertex form? You're going to substitute the opposite of this here. Opposite of 1 is negative 1 is positive 1, and your y value was 2. Because we said the vertex was negative 1, 2. So I could have just plugged it in. Now, how are you going to write this one in x-intercept form? You can't, because there are none. Okay, and go to the back page. The last form is x-intercept form. What's so good about x-intercept form? There's 2 things that we like about x-intercept form right off the bat. That number, that a value, tells you if it's up or down. This one happens to be down. And these 2 opposite numbers will tell you your x-intercepts. So 3 and negative 5 are your x-intercepts. So let's look at a problem. This is written in x-intercept form. What do we know about this? We know it's what? It's down. We know that our vertex is going to be a max. We haven't found it yet, though. What else do we know? What are the x-intercepts? 4, 0, and negative 2, 0. Could you please plot those for me? 4, 0, and negative 2, 0. Now, this thing's going upside down, right? What important point lies in the middle of the road here? The what? Axis of symmetry. Could you figure it out just by looking at this graph what it's going to be? What is it?
1.
X equals 1. Now, how could you figure that out another way? You could add these 2 up and divide by 2. So x equals 1. So that's something you should think about doing at times. Now, if this is going to be your axis of symmetry, what point lies on the axis of symmetry?
The vertex.
The vertex. How are you going to find it? You're going to plug 1 in here. 1 in for x. So do the math. What's negative 1/2 times 1 minus 4 times 1 plus 3? So we have negative 3 times 3 is negative 9. So it's negative times a negative. This is going to be 4.5. So over 1 up 4.5. 1, 2, 3, 4.5. Right there. That's your vertex. So now can you tell me what your range is?
Y is less than or equal to.
Y is less than or equal to 4.5. Now, how do you find, the domain we said is all real numbers, that's an easy one, memorize that. Your y-intercept, there's a couple things you could do here to find this. What's one thing you could do to find the y-intercept? What's one automatic thing you can do? Put 0 in here. So you have -1/2 times 0 minus 4 times 0 plus 2. Anyone have an answer yet?
4.
It's what?
4.
So 0, 4 is your y-intercept, and I have it graphed right there. And you could also give me the point across, which is gonna be that point right there. Is there another way we could have figured out the y-intercept? Is there another way? Could we have transposed this into another form? Can you FOIL x minus 4 times x plus 2? Can you FOIL that? What do you get when you FOIL this? What do you get when you FOIL that?
X squared
X squared
minus 2x.
minus 2x minus 8. But what number is in front of that product?
-1/2.
So if you were to distribute that, you get -1/2 x squared plus 1x and plus what?
4.
Guess what that 4 is?
Y-intercept.
That's your y-intercept. This is polynomial form. What was so special about polynomial form? That's your y-intercept. Now, how could you have written this into transformation form? That's what you need. You need the vertex. Does anyone think they could give me this in transformation form? Your vertex is 1, 4.5. You need the a value. X
minus 1 squared minus or plus 4.5.
and that's the equation in transformation form. You've got 6 problems to do for homework. And I have another worksheet that we're gonna be spending tomorrow doing, so if you're not gonna be here tomorrow, please grab this. It's all of what I just talked about.
Yes.